What's up, team? Today I'm here to talk to you about solving systems of equations by graphing. So we've graphed linear equations before. We know y equals mx plus b. We know how to find the slope. We know how to find the y-intercept. So we're going to utilize those skills today. So what is a system of equations? Great question. So a system of equations might be a system that looks like this. You have multiple equations. In this case, we have two. And to solve this system, and this is something you're going to see time and time again throughout this month for this topic here, to solve a system of equations, you are aiming to identify the correct pair of x and y coordinates that make both equations true. So you're not only trying to solve the top one to find the x and y that makes these things true, but the bottom one as well. So there is one and exactly one combination of x and y coordinates that make both of these true. So that when you plug in the same x coordinate for this x and for this x, the output, the y's, are going to be the exact same y values. Three different ways to solve systems of equations. Today we're going to explore the first one, and it's by graphing. So what we're going to do is we're going to graph this line. We're going to find the slope, find the y-intercept, plot the dots, connect the dots like we've done, hundreds of times before. Independently of that, we're going to do the same thing on the same graph with this equation number 2 here. After we have both of the equations graphed, we're going to look at what we have and see where the two lines intersect. It's at that point, and at that point alone, where the solution of our system of equations lies. So we're going to do it by hand on the board here. I'm going to pull up a graph. Then we're going to do it on Desmos. And then I'm going to demonstrate to you once why it's true. We're going to kind of check our answer. So you'll see how that works as we go. Okay, I'm going to set up my graph now. Okay, I'm projecting Desmos on my whiteboard. I know it's not perfect. Thanks for dealing with me here. Okay, so this first one, y equals 5 halves x minus 4. Here's our first equation. So what we need to do here is identify our slope, identify our y-intercept. We know that our slope is 5 halves, and our y-intercept is whatever our constant is, -4. So let's go ahead and graph this line. Y-intercept at -4, starting at the origin, going down 4 units, 3, 4, right here. And slope of 5 halves. So that means we're going up 5 and we're running 2. So rise 5, 1, 2, 3, 4, 5, run 2, 1, 2. And for funsies, I'm going to do it again. 1, 2, 3, 4, 5, 1, 2. Here we go. We have 3 points on our line. So I'm going to connect these lines because there are solutions everywhere in between these lines and forever more. So let's carefully do our best to draw a straight line, knowing it's not going to be perfect, but we gave it our best shot. Okay, there's one of our equations graphed. Let's go ahead and explore this next one. Here we have a slope where it just looks like a negative sign, but we know that when we have that, there's an implied 1, so we have a slope of -1, and I'm going to represent that as -1 over 1, so we have our rise over run. And our y-intercept here is +3. Okay, here we go. 1, 2, 3, 3 up from the origin. And then slope of -1 over 1. So that means I'm going to go down 1, run 1, down 1, run 1. Oh, it ends up being at the same point. Down 1, run 1. And of course, this goes on forever. Let's connect the dots. Let's see what happens. Something like this. Something like that. My lines aren't perfect, but they're close-ish. So it appears to me that these two lines intersect at x-coordinate of 2 and y-coordinate of 1. It seems to be that 2, 1 is our solution, meaning if you plugged in 2 for x here and 2 for x here, that the solution to both the y's would be the same. Let's check this out on Desmos, and then we'll do it algebraically as well. Hey, I'm down here now. We're in Desmos. What I've done is I put both of the equations of the lines in here. Y equals 5 halves x minus 4. Y equals -x plus 3. So when I click this little box here, it's going to put the graph of the line in. The first one, this is the blue one that we did first. Y-intercept of -4 has a slope of 5 halves, and it keeps going forever and ever. Cool. The other one, y equals -x plus 3, put that one in. Y-intercept of +3, and it has a slope of -1 over 1. We see that they intersect, and they intersect right here at 2, comma 1. Nice. Okay, so that matches what we had hoped. Good deal. Okay, one more thing I want to show you. I want to show you algebraically why the heck this thing works. It's not just math magic. It actually makes sense. So one more thing I want to show you. Okay, here's the payoff. Here's the point where I hope you believe that everything we've done is now true. So our claimed solution here is 2, comma 1, meaning the x-coordinate of 2, y-coordinate of 1. And I said at the front end of this thing, the solution to this system of equations is the combination of x and y coordinates that makes both equations true. So what I did is I just copied the equations over. I didn't do any math yet. We're about to do that piece of it. So what I'm going to do is I'm going to substitute this value of 2 in for x and for x, and then this value of 1 for y and for y, and we're going to see if both of these equations end up being true. So here we go. Let's make it happen. I'm going to make the substituted values, the y values are going to be in red, and the x values are going to be in blue. So our y value is 1, so I'm going to say 1 equals, now our slope of 5 halves stays 5 halves, but we multiply it by x, and we claim that x equals 2. That's our belief at this point in time. We're here to check it. And then the minus 4 is still minus 4. Okay, let's simplify this thing and see what we can learn. On the left-hand side, I'm going to keep 1 as being 1. On the right-hand side, I have 5 halves over 2. Well, this is the same thing as saying 5 over 2 times 2 over 1, and then minus 4 is still minus 4. Now let's simplify this thing. 1 equals, well, with fractions, when we multiply them, we go straight across the top, straight across the bottom. 5 times 2 is 10. 2 times 1 is 2. Taking it one step further, 10 divided by 2, that might be in the back of your head. You may need a calculator for that. Either way, it's going to end up being 5. Minus 4 is still minus 4. This minus 4 has not changed. It's been with us the whole entire time. Now, 5 minus 4, of course, we can combine those terms, and we end up learning that 1 equals 1. And that checks out. Because the left side equals the right side, they have the same exact value. That tells us that this solution definitely is this combination of coordinates here is definitely a solution to this equation here. Now, in order to say that it's a solution to the system, we also have to show that it's true for our second equation. So I'm going to do the same thing. I'm going to substitute the 2 in for x, the 1 in for y. And let's see what we learn here. So y is 1, and that equals negative x. In this case, that's a 2. And then the plus 3 stays a plus 3. This one will go a little bit quicker. You probably already see where it's going here. So on the left-hand side, 1 is still 1. And on the right-hand side, negative 2 plus 3. Well, if I owe somebody $2, but I pay them $3, well, now I'm ahead of the game, and I'm up $1. And we learned that 1 equals 1 again. So what this tells us, we got 1 equals 1 for both equations by substituting our claimed solution in. This tells us that we have indeed found a solution to our system of equations. The only possible point that is the solution to this system is 2, comma 1, where x is 2 and y is 1. Here is our demonstration of that, and the way that we found it is by graphing. Okay, solving systems by graphing equations. Remember, y equals mx plus b is huge. Be careful when you graph these lines. Use a straight edge. Use Desmos if you feel like you need to. And be extra careful because what you're looking for is where these 2 lines cross. So if you draw a squiggly line, your solution isn't going to be exactly right. Okay, this is solving systems of equations by graphing. I'll see you next time.